Hello, let us solve one question from CSIR NET 2020 November Real Analysis Part C. The question is, let fx equal to e to the minus x and g of x is equal to e to the minus x square. Then which of the statements are true? The option 1 is both f and g are uniformly continuous on R. F is uniformly continuous on every interval from closed interval a to infinity for every a belongs to R. Option 3, g is uniformly continuous on R. And option 4, fx into gx is uniformly continuous on R. Solution. If f is continuous on R, then it is uniformly continuous on R when the limit exists finitely at minus infinity and infinity. Means if we find that the limit at minus infinity and infinity is finite, then the f is uniformly continuous on R. Now, f of x is equal to e to the power minus x and g of x is equal to e to the power minus x square. Let us find limit x tends to infinity. F of x is equal to limit e to the power minus x tends to infinity is equal to e to the power minus infinity is equal to 0. Now limit of fx x tends to minus infinity is equal to limit x tends to minus infinity e to the power minus x, which is equal to e to the power infinity is equal to infinity. Similarly, for limit gx x tends to infinity is equal to e to the power minus infinity equal to 0. Limit g of x tends to minus infinity is equal to e to the minus infinity is equal to 0. So fx is not uniformly continuous on R because when x tends to minus infinity, the limit is not finite. But the gx is uniformly continuous because we get when x tends to infinity or minus infinity, the limit is exists finitely. So fx is not uniformly continuous on R, but gx is uniformly continuous on R. So for option 1, both f and g are uniformly continuous on, it is not true because f is not uniformly continuous on R. Option 3, g is uniformly continuous on R, it is true. Now for option 2 and option 4, product of f of x and g of x is equal to e to the power minus x into e to the power minus x square continuous on R. Now limit x tends to infinity f of x into g of x is equal to limit x tends to infinity e to the power minus x into e to the power minus x square, but the limit of e to the minus x square when x tends to infinity is 0, so the product limit is also 0. Similar for limit f of x into g of x when x tends to minus infinity is equal to limit x tends to minus infinity e to the power minus x e to the power minus x square is equal to 0. So f of x and g of x is uniformly continuous on R. Now for option 2, when x belongs to closed interval a to infinity, a belongs to R, we have to find limit at a exists finitely or not. The limit x tends to a, f of x is equal to e to the power minus a exists finitely. So f of x is uniformly continuous on closed interval a to infinity for a belongs to R. So for this question, option 2, given that f is uniformly continuous on every interval closed interval a to infinity a belongs to R, it is true. And option 4, f of x into g of x is uniformly continuous on R, it is also true. So for this question, option 2, option 3 and option 4 are the correct answer. Thank you.